Assalamu alaikum, this is Amal. Today I'm going to present torsion and drawn propeller shafts. Propeller shafts are critical components that transmit motor torque directly to the propellers, enabling flight. The strength and reliability of these shafts directly impact UAV performance, stability, and safety. What is torsion? Torsion is the twisting of a shaft caused by an applied torque. When torque is applied, the shaft experiences angular deformation, called the angle of twist. This creates shear stress within the material, which is critical to understand for proper shaft design. Motor power and torque are directly related through angular velocity. The fundamental formula is T equal P over omega. Defines the relationship where T is torque, P is power, and omega is angular velocity in radians per second. Calculating torque from motor power. Here is some steps of the calculation. Shear stress distribution in shaft. Where torsion is applied to a shaft, shear stress develops throughout the cross-section. The stress varies linearly from zero at the center to maximum at the outer surface. This distribution is described by the formula tau equal T multiplied by R over J. Understanding the polar moment of inertia. The polar moment of inertia quantities a shaft's resistance to a torsional deformation for solid circular shafts. It depends on the fourth power of diameter. A larger J means greater resistance to twisting under applied torque. Failure due to over-torsion. Excessive torsion in propeller shafts leads to critical failure modes. Material yielding when stress exceeds yield strength, shear failure from catastrophic fracture, and fatigue cracks from cyclic loading. Incorporating appropriate safety factors in design is essential to prevent these failures. Determining the required shaft diameter. To prevent torsional failures, we rearrange the shear stress formula to solve the shaft diameter, like shown. Example of calculating shaft diameter as given. We have the torque. We apply formula for D, substituted values in D, calculating D, and we get the minimum shaft diameter required, which is 4.67. Calculate the torque produced by a drawn motor using the formula T equal P over omega. Given specifications, motor power equals 750 watt, rotational speed 8,000 RPM. Convert units and solve the torque in Newton per meter. Given the torque values calculated previously and the material's allowable shear stress limit, determine the minimum shaft diameter required. Apply the formula D. Use formula from earlier slides to verify your results. And then this is some calculations. The key concepts. Torsion occurs when torque twists a shaft, creating shear stress that is maximum at the surface. Key formula include tau equal T multiply by R over J for stress and D for diameter sizing. Proper design prevents failure. Real-world UAV shaft examples. Exploring different UAV shaft designs, materials, and typical specifications used in modern drone propeller systems. Best practice in shaft design for UAV. High strength materials like titanium alloys or carbon fiber composites always include safety factors of 1.5 to 2 for unexpected loads and dynamic stresses. Schedule regular inspections for fatigue, cracks, and wear. Optimize shaft diameter to balance structural strength with minimal weight for flight efficiency. This is some of the resource and references. Thank you for listening.